everyone, I'm Yelena. So tonight it's our Spark Machine Learning Library session. So the goal is to help you with assignment 2 and not just that, just to give you a bit more, a bit beyond of what's in the classroom, all right? So here is the agenda. You're learning new skills, right? Okay, some key reminders for assignment 2. I'm gonna show you a little bit details about the Markdown for Jupyter notebooks. We're gonna talk about the source of most of the students' error in part 2. That's a parser function. Well, okay, so you're gonna be using the pipeline to run logistic regression, and I'm gonna give you a lot of tips, and I'm gonna give you another example, all right? Framingham data. You're gonna get a copy of the data and the notebook, all right? Then this is just a bonus. You don't have to do correlation plots in yours for your assignment, but it's just something for you to take away with you, okay? And of course, your questions, right? So what are you learning here? You're learning here the data management, right? So in a past coursework, you you save data on a PC, right? Or maybe on a, you probably may not have worked in the cloud the way you're working it right now, right? You're using the services, but you have to learn how to manage your resources. So how many people ran out of capacity hours yet? Hopefully no one, but every semester there is at least one person who is. So there are a lot of benefits of using the cloud, right? Including the storage, right? But your storage is limited because of the plan. However, it's probably more than you can store on your PC, right? But again, you have to learn how to manage your resources. All right? Ages ago, it used to be unlimited, but people forgot to stop the kernel. The runtime environment kept running and it kept burning resources. So then IBM decided we're gonna put a limit, right? Okay. Now, every semester, I'm a broken record here. I have to tell you, do not enter credit card number. Trust me, this semester somebody already did it. I'm not gonna mention any names to keep it confidential, but we had at least one or two students this semester who did enter credit card number. I'm not sure how else to emphasize it, but please don't, okay? All right. So, please do not upgrade your account. Some people think that if they put the credit card number, they're gonna get more hours. No, you don't. And this cannot be undone. And you'll be not only responsible for incurred costs, but you might not be able to get help because I don't have the paid account, I have academic account. There could be different applications that are available, right? So just bear it in mind. Please don't do that. You want to stop the runtime environment before you exit, right? If you don't, it's gonna run and continue consuming hours until the session times out on its own. So sometimes you will see that hours used are bigger than 10. How does it happen? Well, if somehow you forget to stop the runtime environment, it will stop whenever it's uh whenever it's run out, right? But it not necessarily stop at the time when your hours run out. All right. So now you have to stop the kernel. But suppose that you forgot to stop the kernel, you can still go back to your account and stop all the runtimes, right? Right. And also, if you realize that you signed out and you forgot to stop the environment, immediately go to your account and stop. Please, uh, just do not exit by closing the browser tab. All right, because that does not stop the environment from running and consuming hours. Here, do not open any IBM tickets unless instructed to. And this semester, I did have to instruct a couple people. And guess what? Did you think IBM helped? Not really, right? So, couple people had issues with their account. Somehow, object storage was not allocated. So, all right, but please do not ask them to help you with the code because they don't know what we are doing, right? Right. So all of you will be submitting the Salesforce ticket for assistance, right? Right. So make sure this is very important. Make sure that the email that you enter when you submit the ticket is the same email that's in Salesforce. Sometimes I get tickets anonymous. It's probably because the email that you entered could not match the email that is stored for you in a Salesforce. So please use the email, correct email, and make sure that the email from the labs are not filtered by spam, right? Right, so now you have to import data to the project before creating the notebook. Do not delete object storage, and this is a very bad idea. Do not open two notebooks in the edit mode in the same time. You're going to be consuming the hours twice. When you run in the notebook, do not skip any cells. You have to run it sequentially, right? Right, because the cell below could depend on something that's created in a cell above. And to get full credit for assignment, your code, you must run all code, and the code must return correct results, right? All right, so all of you remember what we're using is Spark 3.4 and Python 3.11. But I have to tell you that some code that you have in this notebook will be duplicated in 3.5. So if you wait long enough to do assignment, if you're doing it after the semester is over perhaps, or wait past the assignment due date, it's quite possible that Spark 3.4 will be replaced with 3.5. And you will have additional work to figure out how to edit the notebook for Spark 3.5. 3.5 is out there. It's just not on a cloud or not on a IBM cloud at the moment. So who's going to be responsible? You are, right? Right? If you wait long enough, there's going to be Spark 3.5 at some point. Not yet, but no guarantee. See? Probably you'll be fine even if they do put 3.5, maybe for a couple weeks or months, they're gonna have both versions, right? Right? Please don't count on it. Do it on time. We have no control over this thing. Right? No. Now what is this? This is markdown cell syntax. Your notebook contains different types of cells. Markdown is useful to describe what your code does, and it's also useful to add the column headings, subheadings, and the table of contents. So to put if you double click on a cell, markdown cell, it will open this code, like it just looks like this. This is a level 1 heading. If you have one hash mark, it means it's a level 1 heading. Level 1 has a different font from level 2. It could be different font, it could be uh, different size, etc. This one is level 2, table of contents. But check out on the slide, and I'm using the slide and some followers, but trust me, this is what's in a Titanic notebook. Uh, how can we make this table of contents? Well, it's bullet list, right? And so hyphen here, it just if hyphen is followed by two spaces. that one, it shows the bullet type. Then, what is in a bracket? Those are the internal links. It's a link to the location in the document. Like, take a look, for example, see this? You have this subtitle label to heading right here, see? And you have above the heading, you have an anchor, Titanic data. So this is where that link takes you. Right? Right? So you have each section has a unique name, and you would probably want to use underscore instead of spaces. All right? I'd use an underscore. And see this A, it means it's a link, and then it's an ID. So that's like a location in a document. And here you specify the anchor. So see, like in the bracket, this is what being displayed. And here, see that hash mark, and then it follows by the anchor name. What else do we have in here? This is an example of the external link. So you have to specify the link text. This is what the user sees, and the URL. So this is just a link to dataset source, right? Right? I'm explaining, and the reason I'm using the slide because for the hour. This is what you're gonna do, right? Right when you're studying the code, you're gonna open it in the view mode. Okay? Now, what is this? This is how to do the table. If you take a look at this, what is this here on Titanic notebook? It's a table. So you have the tab, HTML tab to open the table, and at the end of the table, you have a closing tab. Then the table consists of rows. TR is the beginning of the row, and the closing TR is the end of the row. Table data is itself, right? So how many cells? One, two, three, four. At least four. So here, this is a cell, and you specify what you want to be displayed in the cell. In this case, it's just the text. But here, this one is empty. Here, in the first row, one cell is empty. Second cell is contains text variable ball, so B stands for ball. Then we've got another cell with description, and then, what we're going to do here? This is the image. So it's not going to look nice if I put the image in a single cell. It will be popping out. So what we do here is that you can make your image span multiple rows. All right? And so I did here row span equals 7. Then rows 2 through 7 you'll have one cell less because you have the last cell here that spans multiple rows. You don't have to add pictures, but I did it just for fun. And what is you have to specify the image URL. This is in this case it's a JPEG, and the file is online. You can go to Google Images and search for an image and then grab the location of the PNG or JPG file. This is just the syntax. HTML syntax for editing image, right? Right? So you do not copy and paste the picture in a notebook. You use this code. You need to find the image on the web if you want to use it, right? Well, so I'll show you. I'll be using the notebook. I'll be showing you different examples. But in the Titanic data, remember this. You need to prepare find the labeled document. So what is this? So you take the data and you split it on a training test set, but first you have to create the labeled document, right? Oops, I'm trying to see. Did someone say something? My audio is muted? I don't think so. Can you guys hear me? Because I did not put on mute.
So now we can hear you. Previously, your voice was so feeble. Looks like you are not close to the mic.
Oh,
Yeah, I think
right.
muffled.
No. How about now?
Now it's clear. Yeah, I was also just typing that message. Thanks, Joseph.
Oh, okay. So it was just last few minutes, right?
Right.
Okay. So what you're gonna do here, you're gonna define the label document. This is what your parser is gonna do. You pass three things. One is it has to be something that identifies every row uniquely, right? And so in the Titanic data, it's a person ID column. Label, this is gonna be either 0.0 or 1.0, depending on the value of the column that you are predicting. Person info is a delimited list of columns that you use as predictor. You're reading one row of data at a time, right? So we define the custom parser function. It's called parse document. What it does, it takes one line from RDG and returns the label document. You apply this parser, but important, you need to exclude the column headers, right? So the way it's done here is that if the row contains column label name, then we skip that row, right? So this is another area where students make mistakes because the data that you're given does not have the column called name. You would have to do something else, right? So that is like a inline function, lambda. So you're filtering it out. If the row contains name, it's skipped. Then you're calling parse document, right? And there's a custom parser function. We're going to look at it in a second. So then it loads the parsed data, parsed. It's loading them into the Titanic data frame. Okay. So I'm going to try to use Zoom. What is going to happen? And I'm going to show you a different example, right? Just an example. But you're going to do yourself a favor. Go ahead and list all columns like this. Remember, in Python, the positioning starts from 0. So when I read a row, in the position 0, I have name because it's the first column. Position 1 is P class. Position 2 is what? A. And position 3 is sex, and etc. This will help you a lot. Why? Well, since you have to create a label document, how you gonna do it? So you're gonna know which column is an ID, right? So person ID is a column in position 5. Column is in position 5. So that's the first parameter. What's next? Well, probably you want to exclude name from analysis. Why? Well, it's a personal identifying information and it does not really help our model. So we're excluding name. Survive is what we are predicting here. Was the passenger survived or not? It's located in position 4. And what you're doing here is you're checking If the value is greater than 0, which means it's 1.1, then survived is what? Is 1.0. Otherwise, it's going to be 0.0. Then here you can see concatenations of all other columns that you're using as predictors. All right? You will need to edit this function for your data in part 2. If you take this function as is and plug it in, you will be predicting if the mother is the smoker, which is not the purpose of the data set for part 2. Right? So just remember this. If you take this as is without any editing, even if it does work, it's not going to be returning correct result because you're going to be predicting the incorrect column. All right? So I explained how this works in the Titanic. Then you split data into training and test set. I do remember that in earlier courses you were told to do 0.7 and 0.3, 70-30%. You can try that also. That's something that you can also discuss, right? But remember those 3 stages that we were looking at? So here you're just running the function, right? You're running this, all right? So part 2 tips. When you load data, and also for part 1, why do we add infer schema? Because we want to read the data. We want to read the data types in the data. For example, age. If you don't do this option here, and you try to analyze the age column, quite possible your minimum age is going to be higher than the maximum age. Why? Because it's going to be analyzing the ASCII value of data, not the value, right? So here is our today's example. It's a Framingham data. So you have these columns here. You have a patient ID. You know here if the person is male, female, you've got the age, you've got their education level, if the person is a smoker, number of cigarettes per day. Notice that more likely there is a little correlation here because if you are smoking at least 1 cigarette per day, you are a smoker, right? 0 is a non-smoker. So you probably, later in your analysis, you probably want to choose one column or the other, right? And so here, just if you're on a blood pressure medicine, well, those are just medical conditions, your blood pressure, etc. And we use that information to predict if the person is a 10-year risk for coronary disease. 1 means at risk, 0 means no risk. So I'm going to go to IBM Cloud now, and I'm going to give you that notebook. All right. So I go to assets, and I already uploaded the data. I want to load my notebook in view only mode. So that way I'm not going to be consuming data. I'm not going to be consuming capacity hours, but I still can show you. So I'm going to do view. Let's see what's going to happen. So when it's a view, the kernel is not running, but you're just starting the notebook. You're opening up. And I'm going to give you the copy of this file afterwards. You get slides, this file, and the data. But it's going to take a while to load. While it's doing that, so that's just the data description. All right. This is a bonus example, and I'll show you the histogram. Okay? I'm going to show you that. Okay. So now it's finally loaded. Okay, so those are just the headings. And notice that when I click on load libraries, it should take me to the section, right? Where it's load libraries. Oops, something going on with the mouse. So that's just, don't want to open in a new tab, but oops, it's something going on with mouse. Oh, here it goes. So see that this was taken to the data. I will leave it up to you, I guess. But remember, your notebook must have some data description. You have the heading here. You do some data exploration. It's very important because you want to see if the column that you're trying to predict is imbalanced. Remember in earlier coursework, you talked about how to handle imbalanced data, right? So you're splitting data to training and test set, and you're gonna build the logistic regression model, predict it for the test data, evaluate, and then the ROC curve plot, right? So what did I do in here? I listed it here as a table. And why am I starting from 0? Because in Python, the numbering starts from 0. I just put the data description here. And you've got this picture here. All right, you will need to play with HTML, but if you don't get it, no worries. All right, so why did I tell you that you need to run all cells starting from the top? Because see the first cell here, this will import the libraries that are used in this notebook. All right, so make sure you do that. You may notice there are some warnings. This is a warning. So in later Spark version, I will have to do some homework, do some modification. It works right now, but later it may not work. I would have to do some code changes, right? So I'm loading this NumPy for some of the analysis, right? I want to analyze data first, but here is a cell that would get students. So in here, you're writing the parser function. It's very important to see at which position the column, each column is located. Remember, you have an identifier, you have the concatenated delimited list of the predictors, and you have the column that you are predicting, right? So let's take a look at it. In which position is the column that we are predicting? It's 16. All right, so you have to look at something. Person ID. Well, in this case, it does not matter what I call it for this one, but it's going to take the patient ID. It's a patient unique identifier. Then I could play around with the combination of those columns. Okay? Some columns are skewed, some columns are not. So here, why do I have a lot of stuff commented out? I try to play with different combinations. At the time, there were 25 capacity hours per month. When I play with it and I said, okay, let me save this example and just share it, right? So this is what it's returning here. The position 0 is identifier, then it's going to return this concatenation. And here I'm looking at this column at position 16. If it's greater than 0, I code it is 1.0. Otherwise, it's 0.0. Okay? Here I'm just accessing data. Very important, when you import the block of code, right? This here, this will be called something else, but you need to rename it because this is how it's named in the rest of the code. So I think it's easier to change this in 2 places than to edit the rest of the code. What is this right here? This is the bucket name. For you, you're not gonna copy my bucket name. It's gonna be your bucket name that you're gonna use later in the code, right? You would have to put your bucket name. Another important line in here is infer schema, because when you're looking at the average, you don't want to look at ASCII values. You want to look at the actual data types. Okay? So this is just output of the first 10 row. You always want to make sure that data is read as expected, perhaps the first 10 row, right? Not a good practice to see the entire data set, but first 10 rows are good enough. Or you can do 20. This is maybe, it may or may not be an example in Titanic data, but that's another way to see the structure. So if I see here that BMI is not read as a double or as a number, then my analysis are going to be incorrect. I don't want to be working with the strings here. I want to be working with numbers in this specific case, right? So this looks correct. I'm just validating. So here, I just want to output the number of patients, and this is just the describe command. It will also list the columns and their data types. It's just another way to see it. What is this? This will show you the number of patients you have for each value of the column that you are predicting, right? So it's just doing a count, and you can see right away the imbalance. See that? Only 644, that yes, and more than 3,000 where it's no. All right? And so here, if you scroll down, this is just more analysis. So more likely, see, you want to look like in the Titanic data, you would probably could say that economic class drive is a very important predictor. So here you also want to analyze the columns and see if based on analysis, you want to try to decide which columns are in this data set, the specific data set. Some columns are collinear. You want to identify that, right? You don't have to in the low birth weight data. However, you probably want to have a theoretical discussion about potential correlation plots, right? So it's just the data distribution, and this is how you can do this plot. And you can tell that the value 0 is a dominant. And this is just by education level, the breakdown. I just showed you an example, and this is the average age of the person at risk and not at risk, right? And it's just the age distribution histogram. But what if I was thinking, wait a minute, Elena, what if you want to look at the histogram for all columns? Are you going to repeat this code 16 times or whatever number of columns is there? Probably not. But I'll show you what I did. But first, here, what is this? In other courses here, we're talking about missing values. If there were missing values, this is how you would have checked for missing values. All right, just know that. It's checking if the columns, for each column is checking the values are null and taking the sum. So this is going to show you the number of missing values in each column. In this case, there are none. But this is just for you something to take with you, that I showed you how you would have kept it if there were missing values. All right. And this is just another way to see the data type. See that? Okay. Now what is this? Those are the statistics. Remember? So you have count, of course, is going to be the same. In this case, mean, standard deviation, minimum, and more. If you see that your minimum is higher than the maximum, more likely you are analyzing ASCII values. You need to go back to where you read the data and add in for schema to remember that one. All right. And what I don't like about it that this column, if the person is a male, I honestly don't like what is taken the way it's taken the average, but that's all right. But just keep in mind this is a limitation. See. Anyways, now I mentioned that I don't want to write the code, separate line of code for each column. Well, fine. What you could do is you can draw histogram for all columns. So here you're gonna pass the data frame name, the list of columns, number of rows. Here, this is the number of rows that you want to have. Like, for example, this is how many columns are in here. So you want to make it readable, all right? This is just the figure size, etc. So here I chose to do 6 rows and 3 columns, just my choice. And what it's doing is just looking through, but probably you would want to check the data type if you were going to go further here. Then if this is not working, then more likely your columns are not numeric, and more likely you may have forgotten to add in for schema when you're reading the data. And this is just I can pick the color, right? I can pick any color. I decided green, right? So this is just will show this plot. You don't have to do it. However, I wanted you to have more. This is a warning. This is not the error, but this code will need to be edited for the next Spark version. So I'm just using the Seaborn package, and I want to display the pair plot. You have seen it in other courses, so why not to throw it in here? You don't have to do it, but I did it for you to show you. What is this? This is a correlation plot. You probably want to at least talk about this in your paper because you want to look at if the predictors that you're using are independent from each other, right? So here the correlation goes between -1 and 1 in general. Well, there is no probably -1 for this data, but either the color code tells you the correlation. And of course, the diagonal here is going to be white because it's a correlation between the column and itself. Right? So you would probably notice that if if person, not model in this case, person, so here, if you smoke at least 1 cigarette, then you are a smoker. So probably there is a correlation between those two guys. So see that this is a cigarette per day, and right before that, if the person is a smoker, see that? So more likely you want to include either one or the other. Right? Then you probably want to check something related to the blood pressure. Usually, if your low region is high, your upper region might be high too. So you want to look at it and you want to then choose the combination of columns. This is a theoretical question. You do not need to write the code for this. You don't need to use other methods, but you need to discuss other methods that you would have used if you were going to improve the method efficiency, right? Some students pick decision tree, some students pick naive Bayes. It's going to be up to you, but you don't have to write the code for alternative method, just for logistic regression methods. But when the hours were unlimited, some students chose to try different methods. Well, not the case anymore. Right? I don't want anyone run out of capacity hours. So, see, this is systolic blood pressure. Usually, if you have a high systolic, you're gonna have high diastolic. So see here, you look at the intersection of the row and the column. So probably this column here is the systolic. So you would have to look at the column position here and the row position and the column position, right? So, and here comes parser thing. You're calling the parser function that we discussed above. So this line, that's a bucket name. It's not going to be my bucket name. It will be your bucket name that you may get either from the project itself or from the code above, the code where you're reading the data. Then you output the first 5 rows. At a moment, the first row contains column headings. Right? So now you have a heading called patient ID. So when we parse the data, we want to skip the row that contains this text patient ID. And we want to call our parser function that we defined above. Right? So then you probably want to check the first 5 rows. If you see the first row with the column names, it means that you may have missed this part here, where we are excluding the first row. Right? So some students forget to change the column name, and the headings are not excluded because there is no such column. Right? Right? So here, do you see this? This is the ID of a person. Person info is a set of predictors that we use to predict what? The last column, if the person is at risk or not. Then what are we doing? We are splitting data into test and training. In this case, I chose 70% and 30%. Then I just display the first 20 records. And then I'm building logistic regression model. Using the pipeline, I evaluate. So we first train the model. The whole idea is, what if we get the new record? How can we use the patient data to predict if that patient is a 10-year risk? So we build the model and we use that model to predict. Is that? So here, what does that mean? In the first row, it's a dense vector. So you have 99% chance that the value is 0. And this is a chance that the value is 1. So the predicted value is going to be the value that has the highest percentage. Right? This is how you would read that. Then you would gonna get the matrix. I should not have printed this whole thing. I should have printed the subset. See, this is a bad. Here, you just want to tabulate. This is not the confusion matrix. This is just the custom table. I want to see how many there were predicted, how many, well, I want to compare the number of patients that are at risk and predicted at risk. They're actually at risk and predicted at risk. The number of patients that are not at risk and predicted not at risk, right? We're trying to get higher accuracy. Right? Then we want to look at number of patients who were predicted at risk but they're not, and vice versa. But keep it in mind that if your data has an accuracy 100%, whatever, or the accuracy on the training set is significantly is very, very higher than the accuracy on the test data, more likely your data is doing overfitting the model. Right? Remember the overfitting piece. So your homework is to review the overfitting and overfitting prevention. So this is your homework. Something that you need to write up. Right? Those are just the codes, and I decided to do this like a table. You can do that too. You're evaluating the model. One thing that I can tell you here is this. Look at the area under the rock curve. That value has to be always between 0.5 and 1. If your area under the rock curve is below 0.5, you need to go back to the drawing board. Something must be wrong in your code. Right, so this is a warning. No problem at the moment, but have to edit for the future. If you get the precision recall, I'm going to leave it for you to discuss those metrics in your paper. Right? And the Rockford plot. The plot took itself a while to generate, but this is how you would plot it. So, all right, you're going to get this notebook, right? You're going to get the data. Okay, right now, I'm going to take your questions. Anyone wants to ask me questions? Yes, so let me see. To confirm. Well, no, if you read the dataset description, right, you're going to see if the baby is at risk for being born underweight. So that's what we predict. But our predictors, in this specific case, you would need to do more analysis because some columns are collinear. They are not independent from each other. So I had to do a little bit of an analysis here, and I was trying to tweak a little bit, right? Okay, no worries. But this is not the case because the data that you are doing for the assignment has less columns. But this is how you would do with the bigger data. So I want you to have this example, right? Initial thought was to give you this for part two, but then when they put the hours limit, I decided no way. We decided to no way. Let's just keep a simple and focus on the concept, right? So uh, I had a very good question from one of the students regarding the capacity hours. So it's not necessarily at the end of the month you're gonna get 10 hours for next month, but it's not necessarily it's gonna happen at midnight. I believe it goes by UK time zone. So probably by 8 or 9, something like that, I get hours credited on the in the end of the month. I get hours credited for the next month. So again, this is not at midnight. Somebody was doing the work at 11 p.m. and they were using the hours of the next month. So you have to be careful. Try to do it if you doing the work on the last day of the month. Try to do it in the morning because at some point you're gonna get the next month's hours. But if you did not use 10 hours for this month, you cannot carry over those hours to next month. See what I'm saying? So this is the reason why you were told to start the assignment, the Spark tutorial early, so that you could use your January hours. You cannot move those hours to February if you did not use them. On the other hand, if you run out, you won't be able to do the assignment. You won't be able to do this assignment until next month. But please do yourself a favor. If you're done with part one, please download the output as an HTML file. Why you want to do it as soon as you're done? Because if you run out of hours for part two, right? And I was a student also. If you run out, then if you have output for part one, you can still work on the write up for part one and you get credit for it. It's better than zero, right? It's better than 0 point for assignment. So you can get a part one and you don't want to be sitting and doing nothing. You want to be working on assignment. You'll be doing part one. And also the last part, these questions don't require using the environment, right? Sorry. So you guys know that, right? As soon as you're done, download, because if you run out of hours, you will not be able to download your work because you have to start the notebook in the edit mode. And you cannot, right? Out of hours, that's it, cannot. And later for next assignment, you'll be using R Studio in the cloud. That one is also using hours, but not as much. This one is 1.5, that one is 1. All right? But next assignment will consist of 2 parts. The database part, DB2, that does not consume hours, and R. So if you run out of your this month's hours, once you're done this assignment, you can still start the next assignment and do the database part. All right? And let's plan to have another session on the DB2, maybe in a couple weeks from now, something like that. We'll see. Let's plan to have a session for it will cover a sentiment analysis tutorial and assignment 3. And pay attention to announcement. The date will be announced, right? Then we're gonna have another session for chatbots, right? So let me have your questions. Which questions while you're here? I'm here for you, right? So who's gonna put credit card information? If people don't ask questions, I start asking questions. No credit card, right? Put your credit card as far away as you can from the desk where you're doing this assignment. All right? That's one way to remember. No credit card. All right? Yeah, that's right. No. Because then this is it, right? You cannot undo, you cannot go back to the academic account. And see, you can get only one code per year. And speaking of that, remember that once your code has only 30 days left, if you still have your student account, your student email, you can still get the next code just for yourself and practice, learn outside of the classroom, right? Right? It does not end. Your experience does not end when the class ends. And you get 4 months access to the classroom, right? I believe it's 4 months. Not sure because TAs, faculty, they get longer. Faculty get longer access. Anyways, so please start early and remember the parser function is the source of errors. Remember that things are case sensitive in Python, right? Positioning starts from 0. I'm just pointing out some areas where students made errors over the semesters, right? Anything else? Going once, going twice? Well, if there are no questions, right, we're gonna call it a night. And everyone, I'm gonna see you in a couple weeks from now. Oh, did you raise your hand, Joseph? Joseph, did you raise your hand? Did you
No,
want to ask?
it was a clapping reaction.
Oh, the clapping reaction. Got you. No worries. So I'm gonna see you in a couple weeks from now. And please do not hesitate to submit Salesforce ticket if you need an assistant. All right? So thank you all and enjoy the rest of your evening. I'm gonna stop the recording. All right.